Hello and welcome to the Ocean Project Stakeholder event. This is a really exciting event for the stakeholders in the Ocean Project. My name is David Patraiko. I'm actually with the Nautical Institute, which is a media partner with the Ocean Project, but this is all about the Ocean Project. So I will introduce Eric Pedersen soon, who will lead you through the things. Just a bit of housekeeping. We really want this to be an interactive event. So at the moment, your microphones and cameras are off, but you can write in comments. Um, when you write in a comment, we do respect your privacy, so we will not use your name unless you put your name in with the text comment. So we're very happy to name check. So just put your name in with it, and we'll do that. If you do want to participate fully with your camera and your microphone, please also mention that in your comment that you'd like to participate live, and we'll enable that. We will enable it first, and then you'll need to click your camera and microphone icon on the bottom of your screen. But that would be great. This is being recorded. The recording will be sent to the stakeholders first, probably in a couple days, early next week, and then eventually it'll be made public. But we do want this to be value added for stakeholders, and those stakeholders who get the early recording, please feel free to share it with your colleagues. If you have any questions in general about the project, or you would like to get in touch with us, the link is there for our website. All the information is on the website. Feel free to look us up and get in touch. We'd love to hear from you. So without any further ado, I would like to introduce the director of the Ocean Project, Mr. Dr. Professor Eric Pedersen. Sir, over to you.
Thank you very much, David. And first and foremost, good afternoon, at least in my time zone, to everybody. Very welcome to this webinar on the Ocean Project. Thank you very much to the Nordic Institute for setting all this up. Very, very competently arranged and organized. This is so nice. I'm Eric Pedersen. Like it was said, I'm a senior researcher at the Western University or University of Western Norway, and with me is Professor Margareta Lutstoft, one of my colleagues. Various partners are on the call, and I will introduce them as they start to present their results of the project. And just as an aside, especially to the stakeholders who have signed up for the Ocean Project, we do apologize. I do apologize that it has been a while since we had a similar event, but now we're here, and we hope that this will be an exciting afternoon and a couple of hours. And like David was saying, we really do hope this will be interactive. We are looking very much forward to your feedback. We are looking very much forward to questions, even the complicated ones where we don't necessarily have the answers, but I hope for a very lively conversation towards the end. So just to remind everybody, and also in the light of this being a while ago, the Ocean Project is all about navigational safety. And it is also all about putting the watchkeeper in the middle of everything. It is on the bridge. Irrespectively of ship size or ship type, it is on the bridge that safety decisions about safety navigation are being made. And so I try to illustrate it as a here and now bubble. This is where things happen. This is very often what we see referred to in incident reports and accident reports, that something happened on the bridge that led to something. And we are from the Ocean Project challenging that a little bit. So we are more seeing it as the end result of a very long chain of events. It is very complex. Of course, the final act may be in the here and now, but leading up to that is a lot of underlying factors. This is what I try to say. It's in the past. We usually try to organize things as organizational matters, as technological factors, as human factors, but they all play together, they all interact, they are all intertwined. And we see that accidents, when they do happen, are very often the product of a very long chain of decisions and events in the past that eventually lead up to something going wrong. So this is our worldview. This is how we look at things, and this is how we have been conducting the Ocean Project. It's also how we are trying to split today's presentation. So we will be looking at this from various perspectives, trying to keep you in the loop of where we are. But as a general reminder, I would like to show what we believe is a very nice video of what the Ocean Project is really all about and all the facets. And that means, Ericsson, back to London, and could you please run the project video?
It is easy to forget that at any given moment there are hundreds of thousands of vessels crisscrossing our oceans. The numbers are just massive. A staggering amount of vessels, people and ports are involved. In spite of its great complexity and the huge number of vessels, the industry has an excellent safety record. That's because seafarers are incredibly capable and rigorously trained. But accidents do happen. Accidents happen not because seafarers are not good at what they do, but because, for a plethora of underlying reasons, they either don't realise there's a risk or they can't avoid it. Ships occasionally collide with other ships, with fixed structures, or run aground. Containers might fall off ships and remain floating, causing risk. And unfortunately, vessels have hit whales, particularly near migration routes. But what if navigational passages could be made even safer by greatly improving the situational awareness of those driving the ships? That is precisely why the European Union and the United Kingdom have decided to fund the Ocean Project. We believe that successful watchstanding happens when humans, technology, and organisational matters like training, procedures, and rules and regulations work in unison. Our aim is to support mariners through equipment that is designed to more directly support human needs. This will increase their capabilities by improving their situational awareness and evasive manoeuvring capacity, rather than by increasing the autonomy of the vessel itself. Open, voluntary, and free sharing of information is at the core of Ocean, because we want to enable the seafaring community to help each other to make even better decisions. This is how it'll work. Say there's a hazard, maybe a floating container or a pod of whales crossing a waterway. The hazard would be spotted by either a person who reports it via our ocean reporting app, or it could be detected by a satellite, seasonal forecasts for marine mammal migrations, or even hydrophones listening for cetaceans. The information would be almost instantly transmitted to a database on shore, which would communicate that to all types of vessels using tools that already exist on their bridges. The Ocean Project will also model the drifting of floating hazards and the movement of marine mammals, so the reporting will happen in near real time, which is crucial to build trust and compel seafarers to take immediate action. Parallel to this, the Ocean Project will develop the Ocean 4D Situation Awareness Display, which will provide an integrated, designed for the purpose, uncluttered and focused presentation of near-field threats and navigational hindrances. The Ocean Project will suggest the creation of a European navigational hazard infrastructure to collect, process and distribute data relating to the presence of marine mammals, floating containers and other dynamic navigation hazards. Ocean's Evasive Manoeuvring Agent, or EMA, will be an improved manoeuvring tool working in tandem with existing ship systems, continuously assessing navigational safety. These tools will mostly be open source solutions, free of charge and subject to voluntary adoption. This project is pulling together a wide community of stakeholders to create powerful and effective solutions. Ocean might not single-handedly solve the challenges that seafarers face daily, but it will definitely be a valuable step towards the solution. Keep Ocean on your radar and subscribe to our mailing list.
Thank you very much. Thank you very much. Ericsson, will you make me a presenter again, please? Good. So just to reiterate, for today's presentation, we have sliced the Ocean project into 4 or maybe 5 areas. So we're looking at the current situation. We are looking towards the future of navigation safety. We are looking at how we have built the foundation for data collection and for data distribution so that we know that we can reach the seafarers with pertinent information. And that is the theme number 4. How do we get there? And what do we actually have to show the mariners to help them stay safe or stay safer? And not to forget, we have a lot of focus on the species preservation of marine mammals. And they are difficult from the perspective that they are unpredictable, but also they are very, very hard to see. So one of the things we want to do is we want to highlight the risk of having a high presence of marine mammals, and we want to share sightings between mariners. So we have a crowdsourcing element, and Dr. Barrow from the Irish Whale and Dolphin Group will talk more about that, or actually show a video, I think, later on. So this is what we have in mind. The headline is certainly true. This is for us an opportunity to get feedback from those of you on the call, and we will open that up later on, as David was saying also in the beginning. And then I will try to conclude with a few remarks. We have set 2 hours aside for this. Whether we will use the full 2 hours is certainly up to people on the call. We will not drag it out. If the Q&A dries up, then we will thank you very much for your participation, and we will close earlier. But stand by for this taking up to the full 2 hours that we thought it might do. Good. So that takes us to the current situation, and we have 3 questions here, and all of this has been all this webinar has been prepared as a series of questions. So the first question is: Do we now know more about what causes navigational incidents? And Margareta, who is a professor of maritime safety here at HBL, will answer that, especially when I can switch to the presentation.
Thank you, Eric. And as you said, this theme 1 is about the current situation, but we will also take a little peek into the future. I'll mention some general comments about our accidents and accident investigations, and then we'll look at some of the identified factors and a little bit of future trends, what we see being accidents in the future. And as Eric has already indicated, we'd like a little bit of a broader view on accident causation, because we see that there are many underlying influencing factors that could be technical, organizational, 2 or 3, all 3 in most accidents. We should look at all of those. However, learning from the past is what we generally do, the mindset we have in accident investigations, and we're also pointing out that we need to be identifying what's going to happen in the future and what kind of methods, predictive methods, could we potentially use to address these future trends. I will give you one data point here, because it was a surprise to us when we found it, and it's been a leading light for much of the work that's ongoing and in the future. Is in almost 60% out of 225 navigational accidents, it was found that the humans involved did not see the situation developing. They didn't see it coming. And that has a great effect on what kind of solutions we will be suggesting to help seafarers do their work even better. Some of the underlying factors that we did see are things like lack of ergonomics, work-oriented design, and consistency of design. And this has unfortunately been around for a long time, and it seems to be quite difficult to address in any way. We also see that technology, and especially new technologies, are both a help and hampers work, where one example could be a decision support system that becomes disruptive in a stressed situation because it's actually taking more mental effort from the operators at the scene than they have to dedicate themselves to handling the situation. Another problem could be that technology would erode experience, which we actually still need to interpret and handle situations on board. One thing that is relatively new in the world of research is how people comply with rules. They are expected to comply with the rules, but we very seldom make an assessment of, is it possible to follow this rule, regulation, or a policy. Procedures, unfortunately, do not always match the way work is done. And the final point I'd like to make is that we are seeing emerging accident factors, which include maintenance and of course, no surprise, IT issue. And so back to you.
Thank you very much. That's very good. Then I will try to work my magical machine again. Yes. So question number 2 here is it's for Ali. Ali is working with the Nordic Institute. You're also a captain, Ali, of long-standing and a long seagoing experience before you stepped ashore and joined the NI, as far as I know. And the question here is, are there gaps in typical maritime education and training? And if there are, how can these be closed? So over to you, Ali, please.
Thanks very much, Eric. Hello, everyone. Yes, it's not an easy question. There are gaps, and to close it, it's not an easy issue to be resolved. That requires a lot of coordination and different approach that could tackle the challenge. Frankly speaking, what we have done in Work Package 2 actually about enhancing professional standard. We did a structure approach according to the Ocean Project grant agreement, and we found that the regulatory framework in somehow cannot cope with the industry swift and progress. That's one of the things we found, giving an example of the model courses and how they are updated and what the industry is doing. One of the other things we found in the literature review, which got an agreement that the soft skills, or we don't like to call it soft skills anymore, but it's the non-technical skills, were not prioritized. Now the industry recognized that, and they are taking further action. Can we go for the next slide, please? Actually, if we look to the industry through different sectors, they are taking their own steps. They are creating their own curriculum, and they are closing out these gaps. So some of the point we found is about the whales and marine mammals, and we noticed that the awareness between seafarers about the topic and the ship strike and what's happening, it wasn't that clear to them. So what we have done is went through researches, attended workshops, and we found that that gap could be closed through enhancing the awareness. But it's not only the awareness to the seafarer, it's also the awareness between scientists, activists, who needs to know more about shipping activity and how that could be done, so the industry will come out with a realistic solution to the issue. We also focused on one essential point. Ericsson can go for the next slide. So we are looking for the feedback of the seafarer or the end users. It's not only about system, it's also about engaging them and having the feedback about their training and their curriculum as well. So one of the surveys we have done about the understanding of the seafarers about the human-centered design approach. And from the slides, you can see that the seafarer expressed their own views, and the majority of them, that's more than 65%, they said we are not engaged in the design process or giving any feedback. No one is asking us. They didn't get any training with that regard, and they are actually the more than 60% are not familiar with the approach itself. In the bottom left of the slide, we also noted that more than 50% of the participants here never thought about reporting or giving feedback. So that's one of the gaps we noticed, and we tried to close that gap by a simple approach, or one approach is just enhance the awareness about this, but further tackles or further solution needs to be there. And we also came out while we are doing our research with, according to the Ocean Project, with 7 gaps. Can we go for the next slide, please, Ericsson? So these 7 gaps, we decided to address it through videos so we can have an impact. We already got a lot of, we got an impact on that. We have around more than 60 institutions, shipping companies are embedding these videos and training videos in their curriculum. With that regard, also we got more than 10,000 views, and these videos are free online. You can watch them in the YouTube, and they are tackling some gaps which we had noticed through our research, and I believe they made an impact. And the QR code in the slide, so you can watch them. And if you want to use them in your curriculum or your training syllabus, they are free. All you need is to sign a consent form for 1 minute, just 1 minute consent form, and they are there ready to use. Thank you.
Oh, thank you very much, Ali. I hope that the main message got across. There are 7 areas identified as in need and want of more attention, and now these 7 videos are I hope for anybody and everybody interested in improving on the current training standards, at least as inspiration. You can use them, you can download them, you can circulate them, and it only takes, like Ali was saying, a very brief filling out of a consent form, and then you're good to go. So thank you very much. Still in the first theme about the current situation, Yudisa, who is a researcher with the National Technical University of Athens, will look into a subject that has been complicated because shipping KPIs are usually quantitative, and the research we have done in Ocean points very clearly to the fact that they are also qualitative, and it is really complicated to combine the two to get a joint picture. And producers have been leading a lot of the work on this and will will now tell us how is that done. Good.
Hello, everyone. So, to answer your question, qualitative and quantitative navigational safety KPIs can be combined, and doing so is not only possible but recommended for creating a holistic and effective safety performance monitoring network. First of all, just so we are all clear, quantitative KPIs are measurable metrics. For example, a number of navigational errors per year or a percentage of ships reaching destination on time. Qualitative KPIs assess characteristics not directly quantifiable, such as organizational responsiveness or communication effectiveness. So during our work in the Ocean project, we created a selection of KPIs that were the most suitable and practically applicable for categorizing navigation accidents, mainly taking into consideration metrics that serve as leading indicators of correct behavior. The selected KPI set was informed by proven industry standards like the BIMCO shipping KPI standard and the tanker management and self-assessment tool to align operations with best practices and drive continuous improvement. Moreover, some qualitative insights were formed derived from earlier work regarding current accident causes and trends in navigational risks. Qualitative insights were then mapped to quantitative metrics. For example, a qualitative insight like crew feels under pressure during port arrivals can inform or be correlated with a quantitative performance indicator like rate of navigational errors during port approaches. Over time, these connections help validate qualitative assessments with hard data. So the quantitative and qualitative aspects that address the same area of operational performance were combined within a multi-layered structure similar to the shipping KPI standard to form a new set of KPIs. In order to reach the final selection of KPIs, the set underwent a series of refinements and additions through collaborative efforts during technical meetings, workshops, online discussions, and a transparent and inclusive polling process. The full set of the final KPIs is publicly available on the Ocean website, along with a detailed report on the work. So combining quantitative and qualitative metrics was crucial as they both contribute equally valuable information and foster a holistic approach to safety management and operational. What's more, the qualitative aspects describe organizational behaviors better, making them useful for creating assessment tools based on measurable behaviors, something that was necessary for following work in the Ocean project.
Thank you very much. If this was your closing line, I think I would like to stress, like you did, and like I'm going to do repeatedly in this webinar, that results are available on the website. All the reports about this are available for download, and obviously they're free of charge. So please go and have a look if this is a concern of yours, and please give us feedback. We still have a little half year to go in the project, and we would very much like to get the feedback from the industry. Also on the applicability of a method like this. Is this useful to you? Is this something that you see could be improved? Please let us know, because this is the only way that we can improve on the quality of our work. So now that was what we have chosen to call theme 1. Now we are moving to the second theme. This is about crystal ball gazing a little bit, looking into the future, seeing what is likely to bring. And the first question is an important one. for especially for design of equipment, and that is whether watchkeepers are behaving the way we think, or the way common wisdom think they are. Are they making decisions in a way that that we believe we know? And or if not, how can that be informed design of the information that people get on board? So
No. Thank you, Eric.
thank you.
Not surprisingly, we do not work as people maybe commonly expect us to work. People are not perfect, and we don't make decisions like machines do. So there are several schools about decision making, and one of them that we will talk about today is called. That's the next slide.
Yep, on it.
Thanks. There are some myths about humans. We tend to think that we are, and when we think about the people on the bridge or on a ship, they should be and are always alert. They see and hear everything, and they make perfect decisions. But unfortunately, the human condition is different for many reasons. There are distractions and fatigue that influence us. As I mentioned in the first slide, there's a tendency, we don't know why, to miss many of the cues that are available in the situation. And we make sensible decisions rather than perfect decisions for one. And one of the reasons we do that is that there isn't enough time to take in all the information. The world isn't a perfect place full of available data, and we never have unlimited amounts of time to process that, to make the so-called perfect decision. Because the situations we find ourselves in the world, and in this case in the navigational context, situations are often incomplete, ambiguous, and changing the information that we get from them. The goals are competing, of course. There isn't just one goal to fulfill when you're on the watchkeeping bridge. Time constraints and high stakes, obviously, in shipping. So what watchkeepers use, and what we can be inspired to take into account when we talk about design, is that we tend to, as humans, and of course in this case watchkeepers, we pattern match what we see with situations that we've seen before. And that's one reason that experience is so important, because if you haven't seen a situation before, you have no idea how to handle it. So they remember a similar situation and adapt a strategy that has been used before. And part of this goes into the concept of situation awareness, which we will be touching on several times today. So to sum up, we're not perfect, but we are sensible.
Thank you very much. Just to elaborate a little bit on that, or if you contrast that knowledge with the way we do design the primary navigational instruments, they are a lot about presenting data to the operator, and that we see right now is not super conducive to pattern matching. So it doesn't really help you without a lot of human cognitive processing. It doesn't help you to recognize the situation, and this is where we believe that we can take design practice forward to have a different focus, to much more to present information rather than data, and to present it in such a way that it is actually triggering the mental structures, the memory structures that people have that will remind them of situations. So this is where, if I'm correct, this is where we see a contribution that could improve on navigation safety. Thank you very much. Then we go now to something completely different. We will look at design practice. So the question here is, can we improve information design? This is very much related to what I just said, to better support watchkeeping. And if the answer is yes, what's in the toolbox? What can we actually employ during design of technical artifacts that will help the watchkeeper towards the end of the day? And I will give the word to Sani. Sani is also working for HBL as moderator and myself. and you have a background in psychology, so you are really the right person to speak about how we can design for the way people think. So maybe you should just tell us what you did. So I understand that you were working with Kongsberg's design team and
Yes.
helping them to become more human-centered. But I understand there was also a second agenda for us as researchers.
Yes, as human factors, we try to help and support them to make these methods applicable in the industry and for the design team. So our main resource and what methods worked for KM was is what I'm going to tell you about, and that's also what we are going to promote in the future. There are a number of key methods that the design team actually tested and followed, and those methods, they fit into the workflow they had, and the team gained value insight that helped shape a user-centered design that truly met the user's needs. By what they did was to observe navigators in simulators while they verbalized their thoughts by thinking aloud technique. The team could identify pain points not visible on paper. So quantitative data paired with qualitative insights allowed team to move beyond assumptions. So some of the tangible resource and what KM team learned was that human factors methods suggested by us as a researcher do work, and the result is clearer usability improvements between the iteration based on real user input.
But I think we also learned a lot because we learned that many of the more formal, more complicated human factors methods, they are very hard to apply in an organization where the commercial pressures are high and the agenda of things are very long and so on. So so we learned how to adapt methods to become useful to the people who are going to use them, rather than something on paper that looks nice but may not really work. Is that a nice way of saying it?
Exactly. There are a lot of challenges, and one of the challenges is actually to make designers, developers, and managers aligned, because they have different backgrounds and experience, and also goals and pressures. So yes, but in conclusion, human-centered design led to a better design awareness, I would say, and faster design improvements, and hopefully with fewer later stage revisions.
I'm sure everybody on the call, and I'm sure everybody on the call can figure out that the two of us, we could talk about this for a very long time. Unfortunately, we are out of time for this session, but I hope that what you have been saying gives an appetite. We are in the final moments of writing this up so that the guidance for human factors application by the maritime industry will be available by midsummer, I think is the deadline, and the reports will be made immediately available on the website, right?
Right.
Good.
Yes.
Thank you very much. So now we have been looking at new knowledge about decision making, that has an impact on design. We've been looking at human factors that has an impact on design. We know how to what we don't know right now is how do we build complex, robust systems, because it doesn't help if a system is advanced if it doesn't work, and if it doesn't always work, and if it's not trustworthy. But I will leave that to Dr. Jonathan Hersey, who is the human factors expert at Lloyd's Register, to elaborate a little bit on this. Jonathan, please.
Thank you. Good afternoon, everyone. Yes, Eric's 2 questions. How do you build robust, complex systems, and what will that do to watchkeeping? In the topic, we've already started to discuss that issue. So the question of how, we do actually know, because there's been a standard around for more than 20 years which tells you how to do this. It's mainly used for the engineering side of the ship. And as you can see, it identifies 20 things, 20 principles to apply throughout the life cycle of a complex system where its failure of function has significance. It consists of 11 product principles, which are requirements on the system itself, and 9 life cycle principles, which are requirements on the development and through life support of a system. Now, the original goal for this standard, which is called ISO 17894, is to assure dependable control systems. But throughout the project, we've been looking at this standard not only within the project, but also going out very broadly and looking at how the standard it's built on are changed, and what the new areas of application in the maritime sector are requiring dependable systems. And we find that a better word to use, a much more translatable word to use, is robust. How do we make complex software-intensive systems sufficiently robust that they can be used, and also how do we make them usable? That's what Sandy and Eric have already been talking about. So how do we achieve those 2 things, which will increase users' trust in those systems? And that, of course, is a word that's coming up a lot nowadays as we move into more social systems such as AI, advanced machine learning on the bridge. So, in other words, we have an ISO defined set of principles, and both for the life cycle and the product itself, which, if applied properly, will increase user trust. In our case, watchkeeper trust. And as we've said, this rigor is increasingly necessary as systems share more responsibility and become more interconnected and integrated and extend beyond the ship. As we've studied it, the principles themselves still work fine, but systems are becoming more complex, more integrated, and their use becomes more dynamic. And the application needs to consider more about the operational phase of systems. There will need to be more feedback, there will need to be more support and understanding through life, and especially user feedback to continue to evolve systems so they apply more precisely to the working environment. How does that apply to watchkeeping? The only thing to say on this slide is that we need feedback on the quality, the safety, usability, and utility of systems in order to continually maintain a balance of competence and usability throughout the life, especially as we move into augmented reality, unattended bridge, and remote control, as well, of course, as increased public surveillance, potential security issues and environmental challenges that that the industry needs to address. Thank you.
Thank you very much. And I don't know whether it came out very clearly, but this work will be documented in a new version of an ISO standard that will enter the process of revision in this autumn, as far as I understand, and then it will go through the motions at ISO and eventually become a new or a new updated version of ISO 17894.
It's actually next week. We will take it to ISO next week. There's more work to do, but we've got an open door earlier than we expected. Thank you.
Thank you. And finally, last but not least, when we look at the future, I mean, now we have seen that people are making decisions differently. We think that making better information available to them is a helpful thing. We know the tools. We know a lot more about building robust systems, also looking into future hazards or threats. But what else, Oli, are we doing to mitigate present-day navigational accidents? You have done a lot of work on that.
So one way we can mitigate present-day and possible future navigational accidents is by creating tools based on current risks and accident causes, current trends in accident types, and excellence models like the key performance indicators. With our work in the Ocean project, we crafted such a tool, the Navigational Risk Awareness Template, designed to raise awareness and support the mitigation of present and emerging risks during navigational safety. As a starting point, we used new data on navigational safety that were provided by re-examining past incident and accident reports, as well as interviewing accident investigators about trends in accident types to identify future risks. We also used a selection of the most qualified and practically applicable KPIs on navigational safety, which represent the status of the industry on navigational risk management and mitigation. After combining this data, a group of our partners with diverse background in the fields of expertise efficiently enlisted a new set of ranked safety constructs for navigation in the 21st century, which were divided into three priority groupings. The first grouping, the reactive behaviors, representing an organization's primary behaviors to achieve navigational safety. The second grouping, the proactive behaviors, representing an organization that actively works to reduce navigational safety risks. And the third, managing behaviors, representing an organization that operates within known safety margins for technical, operational, and organizational sources of navigational risk. When using this tool, the assessor is asked to answer with yes, maybe, and no, according to their organization's way of working. They would need to interview colleagues or at least have conversations, as the template brings together knowledge about management, navigation, technology, including IT, and increasingly the organization's approach to the human element. And not all this information would necessarily be available in one place in the organization. This assessment method is designed to raise awareness on present and emerging risks to navigational safety using process improvement techniques, which are in line with modern quality-centered management. Although the resulting tool itself has not been widely applied or rigorously tested in its new form, it is based on validated data and established good practices. It will, of course, need regular revision because technology, competence, and regulatory requirement on navigation are all changing fast. More usability and utility testing of the tool will be applied until the end of the Ocean project. The Navigational Risk Awareness Template was evaluated by a human factors specialist and accident investigator and the P&I director of loss adjustment. with the conclusion that there can be use of simple risk assessment tools of these four, both in prevention and investigation of navigational accidents. The navigational risk awareness template and the detailed report on how it was created are also publicly available on the Ocean website. Thank you.
Thank you very much, Oli. And just to say it again, we would really love that somebody among our stakeholders would actually try this out and give us feedback. And the more the merrier, I think, is really the point here. Again, this is a way of refining what we have done to hear from people who try to apply it and see what happens. That takes us to the third section of this. You heard in the project video that some of the problems we are looking at in the ocean project is what we could call hidden hazards. And especially two things have received a lot of focus. One is containers lost from container ships, but remaining afloat, more or less visible, usually less. And the other is how we can share the oceans with marine mammals. Because we know that there are ship whale strikes. We know that ships are going where there is an identity of whales. And we know that it is impossible for the mariners with the tools they have right now to know it and to take any kind of action. So marine mammals are being killed. And I'm sure that Rui, when we get to that, will speak a lot about this. But first and foremost, there is also a quest to collect that kind of data and collate it and make sure that the seafarers can receive them and use them. And this is where the European Navigational Hazard Infrastructure comes in, and that is a database system that we have been designing and that is now operational. I hope Francisco from Chimne in Barcelona is with us on the call.
Good afternoon. Thank you. My apologies because I'm not able to connect with my PC. Probably something has not recovered after the blackout 2 days ago here in Spain. The European Navigational Hazard Infrastructure, what we call the ENHI, is a software development that can be understood as the combination of four main capabilities. Please, Ericsson, next. First, what we have is the implementation of input and output interfaces that define how the data is exchanged between all the components of the ocean ecosystem, and mainly using JSON standard, but also featuring an implementation of the incoming S124 format when it comes to the generation of navigational warnings. Next. Then we have a robust database management system with persistent storage and archives, and also providing concurrent and optimal access to the data that we receive. Next. We also have efficient management of the data, ensuring its accuracy, consistency, and also avoiding duplicates. And last but not least, please, Ericsson, we have the possibility of serving navigational warning information to the ships to improve their situation awareness. Next. So the diagram that you can see illustrates the role of the ENHI in the ocean ecosystem, as well as the main data flows between the components that can interact and send and or receive reports from detections, observations, and predictions. On the left side, what we can see are the components that operate independently, such as the hydrophones that can detect certain species by means of passive acoustic monitoring. We have a progressive web application and the 4D SID that can report sightings as well as display the hazards. And we also have the environmental niche models providing predictions about marine mammals presence, depending on parameters like, for example, the water temperature. And then we have also two on-demand components that can be optionally triggered to provide complementary information to a given report. We have the satellite imagery analysis of a specific geographical scope and time interval in the search of both containers and cetaceans. And also we have the simulation of a container trajectory based on the OpenDrift modeling framework, that is the container drift. And finally, all the data that we compile from those heterogeneous data sources can be used to generate navigational warnings depending on the filters used by the end consumer. As previously mentioned, we can generate this information in both GeoJSON and S124 format. So finally, the way the interfaces have been defined and how the software has been designed allow easy scalability of the system in terms of additional object types supported to report hazards, integrate new data sources to the infrastructure, or even to integrate the infrastructure in a system of systems to increase the impact and improve the support to the mariners during navigation.
Thank you, Francisco. I'm afraid I need to cut you short there. If you have more to say, then I'm very sorry.
No, that's the last slide.
But and then there's one thing that maybe didn't come out very clear, and that is that the ENHI is all implemented, it's all running, it has been tested, it has also been saturation tested. We know it's robust, we know it's available, and our great hope is that we can keep this running for the near and maybe midterm future, to enable people to exchange data with it and to eventually to inform the mariners. Is that correct?
Yes, that's correct. So users that wish to use the system, they can register the system right now. It's now working, and they can use it.
And as an additional benefit, this is open source code, so anybody who wants to create an instance of the European Maritime Navigational Hazard Infrastructure can do so, right?
Exactly. That's right.
That's quite fantastic. Thank you very much. That takes us to Rui, who is a professor at the University of the Azores, who is also, I think, without saying too much, a world-renowned expert on marine mammals, and who have been looking into one of the data sources that are feeding into the ENHI you just saw, which is the environmental niche model. So, Rui, please take us for a dive into this.
Yes, good day. I hope you can hear me. Just confirm that to me, Eric. Yeah, okay, thank you. So I can see that everyone is hearing me. So yeah, it is kind of an issue. So we know that there is this problem, the ship whale strikes or ship strikes for a short. And why does this matter? Is it important? Yes, we think that probably there are thousands of whales that are killed every year by ship strikes or injured as well. But it's difficult to estimate because most of the times they go unnoticed. The ships are so big that that mariners are unaware that they actually hit a whale or any other organism. So it is a problem. It's an issue, a conservation issue. And I know that the mariners that are out there and hearing us here are kind of asking. So if the animals are there, how can I actually do something to avoid that? Because if it's difficult to see them, how can I know when I have to take action? And that is what we are trying to do with Ocean. What we need to do is to have the information on the in front of the mariners in a way that they can use it preemptively. So what we need to know is, are there animals somewhere, or can we at least predict that an area is an area that will have animals present at any given time? And that is when the environmental niche model or species distribution models enter into the equation. Well, what we are doing is kind of trying to forecast the weather, but with whales and other animals. So how do we do this? We need to know by surveys, for instance, where we see animals, where we don't see them, and then with that information, we cross that information with the environmental variables that are present in the areas that are they come to, and the environmental areas where they are not present. And we use statistical models to try to understand what it is that attracts the animals, that makes the animals like one area, and then project that into other areas and in other times. And by doing that, we can try to predict at least areas where the animals are going to be present. And then using what you just seen, a system like the EMRA, we can show the mariners in advance where they should take some preemptive action, either by reducing speeds or by totally avoiding that area, because it's an area that we think that there is going to be a very large concentration of animals. And that is the power of what we are doing here in Ocean, is that we are giving that information in an actionable way to the mariners so that they can act onto it and do what they want to do, which is avoiding any incidents. Does that respond to your question, Eric?
I think it does, and I think it does, and to augment that, I mean, the environmental niche models are not our only trick in the box. So we are also, some whales are verbose. I mean, they are making sounds. And
exactly. There is no single.
If we switch to Harvey, then Harvey can explain to us how Teledyne, where you are software director, director of development for software in Teledyne Reason, and you can tell us how you have adapted your technology to be very useful in finding and pinpointing whales actually in real time.
Thanks, Eric. I hope I'm audible for everybody, and you can see my screen.
Yep.
Very good. And then I think on your first sheet for this section of the presentation, there was this question: can passive acoustic monitoring systems help to detect marine mammals? And I think yes, absolutely. However, I do need to emphasize and maybe also explain a bit that going from the question and the answer, it is a very steep learning curve from going from we have an idea on how to do this and actually how to get there. But it was, despite being a steep learning curve, also a fun ride. So let me show you in a couple of sheets how we came to what we have as the last success in this project. So we came from an idea of having buoys in the water to carry some kind of apparatus, whatever it would be, to listen to sounds in the ocean. Filter out what is interesting for the ocean project, meaning sea whales, sperm whales, and organic sounds, and then georeference what we have found with the listening system, and maybe then upload that to the cloud, and the cloud uploaded to that system Francisco just showed, the EMRA system. Well, actually, I should also mention testing. This whole idea of getting from nowhere to making a full system means testing, field testing, and more testing. It's not just that you just build this and then it works. So that means it's really an innovation process, which made us do lots of small and large tests with our equipment. And the nice thing about having such a research project, of course, is that you will have small iterations, which are small steps to the next portion of the project in which you can have a success, which is always good if you have like a long project running. I'm showing this sheet here, and just very quickly, the first idea we sketched up was this colorful diagram in which you can see what needs to be in the buoy, what needs to be in the cloud, what needs to be in the embedded computer. You can see somebody sitting patiently listening to dolphins in the dolphinarium in the Netherlands. You can see a what we would call a passive acoustic monitoring system on a tripod, and we put it in the harbor of Copenhagen to listen to these harbor buses transporting people back and forth, to see if you can listen to them as first, just to make sure that the basic idea did really work. Then after that initial phase of, okay, apparently what we have figured out seems to work, now let's make real use of the technology and get into how to do sophisticated analysis of sounds in the ocean and get sperm whales out of that and geoposition them into a detection which can be uploaded. We definitely first thought about, okay, what about the buoy? And then we selected the buoy which was best for this project, and we stuffed it with lots of equipment. First of all, solar panels, batteries, embedded computers, GPU systems, hydrophones, motion sensors, position sensors. The whole thing was fully loaded. And well, whenever that whole mechanical electronical system was figured out, we went into, okay, what do we do with machine learning? What kind of machine learning do we apply to make sure that the whales can be detected as best as possible? But anyway, you don't want to listen to everything, so you need to filter as much as possible. Meaning you want to have like a beamformer to make sure that where you are hearing sound of, you want to know, is this sound where we were hearing sound earlier? Can we correlate to previous sounds? And with all that kind of technology, you need like sophisticated software to make sure that technology also works together. And that is where that whole diagram you can see at the right bottom corner is for. That's the basic diagram of the embedded software running in the buoy, doing all this sophisticated calculations, correlations, and well, what more. So in the end, we ended up with a buoy which really is deployed in the ocean. The picture you see here, which I think is a very pretty picture, is at the Azores. We had 2 buoys deployed. The 2 buoys were actually detecting sperm whales. You can see in the map, which is actually a cloud application we have developed, where the 2 buoys are positioned. Detections of the sperm whales would be plotted in this application also. The 2 buoys were sending their detections up to the cloud. The cloud application would correlate, see if the detections are actually the same whale. If it's the same whale, they will make the qualification of the whale a bit more robust. So you can then have like a better quality detection, which is always good for the systems which are listening to this and using this into a fusion of information. And just as a gimmick, I also have this plot you can see, this animation in which we literally, you can see the whales swimming around the buoy. This is a long distance range. This is not like close by of the buoy, of course. And then, well, this is what we track. And you can see 2 buoys now going down. The third one is just hovering a bit in the bottom. They're making some kind of curves, and there comes a third one in place. And then, well, it goes around and around. It's just a short looped animation. So in that sense, I think we had the good success building the buoys, deploying the buoys, testing the buoys, and literally doing the detections of these whales. Last but not least, I think it's worthwhile to mention that most of the development we have done is open source. It's open source via the Ocean website, as Eric already mentioned earlier. There are reports of our development, of how to build a buoy, how to integrate software with the buoy, how to develop the software, how to do the machine learning model. And that, in my opinion, that report is very elaborate. It's free to download. You can just pick it up and use it to your own benefit. But I think most important is, next to the open source report and the open source source code, I think I should encourage the audience to have a look into this and maybe get inspired themselves to go to the path we have gone. There's much more research to be done, and there's much more software and system to develop in the domain to make sure our whales and our navigators are safe.
Thank you very much.
Oh, good. Back to you, Eric.
Thank you. I think it is very important that we are giving this back to the community. It is there for inspiration. It is also worthwhile to note that the testing that you did was actually a very solid proof of concept. So we see that the buoys were there. We saw We were lucky enough that there were whales around during the test period. We saw that they were detected. We saw they were reported. And we are actually able to take those recordings from that and push through the entire data chain. And we can see that it shows up on displays in front of the navigator. We will get to that in a little while. We do need to speed up, possibly, but we have a lot to tell. So that's how it is. And yet another data stream has been created by the University of Barcelona, who are expert in image analysis and also the use of AI. And unfortunately, Ludwig, the chief scientist there, could not join us for today. It was a last-minute emergency. But I believe, Ericsson, that we have a recorded session from Ludwig that can inform us.
Yes, indeed. I'll play that now.
Eric, hello everyone. The answer is yes. We can detect whales and floating containers in satellite imagery. So here are some of the steps which we follow to detect whale from space using AI. First, we looked at whale aggregations, meaning seasonal whale gatherings in high-resolution satellite imagery. Typically, the resolution is between 30 and 60 centimeters, and you can see below what different species look like at that level of resolution. Second, we built a database for multiple species of whales that includes blue, fin, right, gray, and sperm whales. This means that we looked at data in a multiplicity of locations, such as California, Mexico, New Zealand, Brazil, and many other locations. Third, we trained many different machine learning algorithms, and we obtained our best results with state-of-the-art algorithms in image classifications. Particularly, the best results were obtained with the convex model type. Then we worked on 4 different aspects. First, the results we obtained demonstrated that large numbers of whales can be detected on a large scale. Overall, we have near 10,000 marine mammals detected or annotated in satellite imagery. We demonstrated robustness by deploying the algorithm over 1 million square kilometers and then retraining the algorithm and curating our database to account for actual false positives and false negatives. We demonstrated that the algorithm could be used to explore remote areas where traditional methods are too costly and too slow to deploy. Then we demonstrated that high accuracy and recall could be obtained at image classifications. The results are presented in the following table for each species of interest. The lowest recall is obtained for humpback whales, which is the most difficult species to detect so far due to its behavior, such as its tendency to breach frequently. Those images give you an idea of the scale at which we deployed those algorithms and the number of related true detections. On the left, those are detections of gray and humpback whales obtained on the coast of California, where we have several thousands detections. And on the right, those are examples of over 100 detections of right whales, which we obtained in the subantarctic Crozet Islands. And this demonstrated that the species is actually recolonizing this area. So great new data for science. Then how did we detect floating containers from space using AI? First, we annotated high-resolution optical satellite imagery and built a database of occurrences of over 5,000 containers located in multiple harbors. Secondly, we trained many different machine learning algorithms and obtained our best results with state-of-the-art algorithms in image detection, such as faster RCNN, and classification algorithms, such as convex models. The results we obtained showed high accuracy, and for the 2 best performing algorithms, meaning the 2 last rows of the tables, all containers were correctly detected, with average accuracy reaching respectively 96.2 and 97.2%. We also analyzed different real-world container spill scenarios and looked for corresponding satellite imagery. The imagery presented here illustrates the container spill incident of the MV Rena, which occurred over several months in New Zealand in 2011 and 12. You can see the site of the wreckage and all the detected containers in the Bay of Plenty. Containers like the red marker, and the position of the wreckage is illustrated with the blue marker. Next, we have some examples of containers detected in satellite imagery. In the middle, you can even see a satellite imagery presenting the rescue mission, which is towing away some floating container. On the right, you can see a container that was sinking and was initially missed by our first version of the algorithm, whereas the final version of the algorithm, we have been using a Connect CNN model, was able to also detect that sinking containers. As a conclusion, not only can we detect wells and containers from space, but we can do so with great accuracy and on a large scale. Thank you.
Thank you very much to Ludwig, even though it is a recording. I think that I'm not an expert on this, but I have been told by people who are that this is pushing the state of the art quite significantly. This is groundbreaking work, and as the analysis of recolonization of the Crozet Islands is concerned, this shows the power of what has actually been developed here. Again, everything is reported, documented, available on the website. So if you have a particular interest in this bit, then please go to the website. So now we have collected a lot of data. We know about containers that might be floating. We know about where the marine mammals are. So how do we get that to the mariners? And I think that Vidar, you are Director of Software Development in Kongsberg Maritime, if I understand correctly. And you have been leading the work on the development of what we call the 4D situation awareness display, which is one of the mechanisms that we use to reach the mariners. Is that correct?
Yes, that is correct. So yes, to start answering this, so can we provide some better information to the watchkeeper and how do we reach them? So the short answer is yes, we can provide better information to the watchkeeper. So starting from the situation today on a conventional bridge, the watchkeeper, you have several sources of information and one of them is looking at the window, of course, and looking at different screens and instruments like electronic charts, radar, AIS. So the situation today is, of course, that the mariner or the watchkeeper needs to process all this information in her hand or his head to understand the situation and then figure out if any actions must be taken. And of course, the issue is also that the information is in different formats, and there are important information and not so important information, and it's quite a high cognitive load, and that, of course, we have learned also earlier today that there is a possibility for the watchkeeper to misunderstand and also not take correct actions. So that leads us to what we have done in Ocean. So what we have tried to do is to present relevant information in one display, trying to remove as much non-relevant information as possible, and also process this information to give the watchkeeper a better view. So the basis here is an electronic chart, but only showing the essential part. The white part here is ocean, and the colored part is land, and so on, and showing the grounding areas, the safety contours along the coast. And what we also see here is that we have our own vessel, some circles there, following a planned route, and we have some detected vessels, the triangles, one red triangle moving towards us and one red triangle moving away from us. And we also have areas, some yellow areas with the detected whales, and some orange areas here with detected containers. So here again we combine information from many sources: radar, AIS, camera sensor, and the rail and container from the hazard infrastructure. So and also we have here an evasive maneuvering agent calculating the collision risk. I will come back to that also later, I think. So yeah, this is in short what we have done to collect all the information in one place for the watchkeeper.
Thank you very much, Vidar. This is exciting. I think I would like to add that it is not meant to replace any of the mandatory systems on board. It is not meant to replace ECDIS. It is not meant to replace radar or AIS. It is meant to have the operator focus on, let's say, the next half hour. So the tactical picture around him, and then we are adding information that is really new. So we're adding the information about the risk of floating containers. We're adding the information about the potential high density of whales or even whale sightings. And it becomes a tool for the close-in navigation, I would say, rather than the tactical or the strategic navigation that is usually associated with radar makers. Do you agree to that?
Yes, absolutely. That's what we are trying to achieve.
This is really good. Thank you very much. What also needs to be said is that we are not done with this. The final step of development of the 4D SAD is going to be a sea trial. So Kongsberg will be fitting this to a test vessel, and we will take it for a spin. And hopefully we will get good results. We will get feedback from the mariners. This is a useful tool also in practice. It has been tested in the simulator. There has been usability assessment of this. But I have really high hopes that it will make a bit of a splash in the industry once we're done with this. So this is really good. Thank you very much. We also have the issue of containers, and I put a question to the Norwegian Coastal Agency, who is also an ocean partner, and asked them, can we warn mariners about lost containers? And can we reduce the risk of that happening in the first place? So Claude, who is working for NCA, have made this nice recording for us that Ericsson will now share.
Good day, everyone. I am Knut Olda, and I work for the Norwegian Coastal Administration as a senior advisor. The NCA has been involved in the Ocean project mainly as a work package leader for work package 5, which is called Tracking and Recovery of Floating Containers. There are two central services that are highlighted in work package 5. These two are warnings from coastal state to vessels that may sail into an area where they are at risk of colliding with lost containers, and warnings to vessels that are in conditions where they are at risk of losing containers. From the NCA's perspective, these two services are highly relevant for us as a coastal administration with responsibilities related to safe navigation and pollution prevention. As described in our deliveries, the identified methods of warning vessels about lost containers can be by traditional GMS systems such as VHF voice, Navtex receivers, and by future technologies such as VDES. The Ocean app introduced by other partners in the projects was identified as an option to the traditional communication systems, and the app also has drift calculation for containers installed. And the app is open for everyone. In addition to warning about already lost containers, it is from our perspective just as important to reduce the risk of losing containers. We were inspired by the Dutch Coast Guard about their solution to issue warnings to vessels in risk of losing containers. Parameters such as wave height, wave direction related to vessel's course, size of the vessel, and dangerous wave areas was identified as parameters relevant for issuing of warnings. The warnings is, from our perspective, most fit to be issued by traditional GMS systems to reach the relevant vessels of interest.
And time is slipping by, so we will proceed rapidly. You heard references now to an app, and I'm sure Simon, who is heading the Irish Whale and Dolphin Group, and who has led the work on the development of an app. The 40 SAD that Vida was presenting is mostly for the solar segment of maritime stakeholders. The app is designed to be for the rest, so leisure, fishery, smaller ships, etc. And it's worthwhile to know that the risk of striking a whale or the risk of striking or bumping into a floating container is much larger for the smaller ships. So the app is really important from this perspective of warning mariners in smaller ships and of helping them help each other. So thank you, Simon. I know you have a video. Do you want to say a few words first?
I will. Thanks, Eric, and thanks, everybody. So the Irish Whale and Dolphin Group are an all-island NGO who coordinate whale and dolphin stranding and sighting schemes, and most reports are sent to us through citizen scientists. And as part of our projects, we developed a recording app to help people report sightings to us. So when the Ocean Project reached out to invite us to get involved, we felt we could use this experience to address the issues in this project. So the Ocean Reporting app was designed using human-centric learning, as we've discussed earlier, to enable all mariners to report sightings to us. But also it was designed so that it would provide feedback to the mariners through the app, through Francisco's ENHI, or the magical black box, as we call it, and it could visualize the sightings, Rui's predictive modeling, acoustic detections from Harvey, and also Ludwig's satellites from space, as well as the containers. So it had two factors. It had one to try and enable people to report things in as close to real time as possible, and also to visualize these warnings to the mariner. And it works very well. But rather than hear from me, we produced a short video just so that your viewers could understand the work in the app better, if Ericsson can play it.
Oh my God, it's right in front of us.
Ship strike is considered the greatest threat to large whales worldwide. A number of initiatives are underway globally to try and reduce this impact. One of these is the Ocean Project. Funded by the EU and the UKRI, Ocean focuses on enhancing the navigational awareness of marine operators to reduce the frequency of severe accidents like whale ship strike. This is achieved by providing a suite of data streams which is then visualized in close to real time to enable mariners to take evasive action if appropriate. These data streams include habitat modeling to predict the likelihood of large whales occurring in a given area, acoustic detections from fixed sonar buoys, the detection of whales from space via satellite surveillance, and a real-time reporting app. The Irish Whale and Dolphin Group was responsible for creating an ocean app to report whales at sea that could pose a potential collision risk, as well as floating containers and other potential obstacles. The app incorporated new thinking on human-centric design, which attempted to prioritize the usability for the user. For example, whale species identification was not important, only whether the whale is a potential ship strike risk. This differentiates it from a biological reporting app that requires extra information to validate species ID. These independent data streams are feeding information to a central database called the European Navigational Hazard Infrastructure, or ENHI for short, which in turn sends this process information back to the user via the Ocean app. This provides real-time data to the mariner to enable enhanced decision making.
The Ocean app is a device-independent, easy-to-use mobile reporting app. It's designed as a progressive web application, or PWA for short, which allows usage across different device types. Once installed, its behaviour is similar to that of a native app. Before you use the app, you need to ensure you have internet connectivity, location services turned on with GPS, and most importantly, you must register. Your home screen is a map with your device location indicated by a ship icon or simplified circular icon when zoomed out. You may see ocean warnings marked as whale or container icons in your visible area. The ocean infrastructure feeds the app warnings from multiple data streams, providing real-time whale and container observations, either shown as individual reports or whale or container areas where there's a high likelihood of encountering those hazards. For example, the Azores. Reporting a whale or container is simple. Provide as much information as you have and feel free to add extra information if you have time. Click Submit and that's it. If you lose connectivity for some reason, the report is stored locally until connectivity has been restored. Reporting a container is just as easy. Again, if you've extra information, such as the company name if it's visible, please enter it if you have time. Click Submit, and again, that's it. As an Ocean App user, you can now make informed decisions to reduce the likelihood of ship strike incidents.
We share the ocean with a wide range of marine species, including whales, and it is our responsibility to minimise any impacts we make. The Ocean Project is just one attempt to ensure human activity and whale populations can coexist with minimal risk to both.
Thank you very much. Thank you, Simon. I think it speaks for itself. We will reach on. Vida a little while ago was hinting that we can actually also help mariners to avoid collisions by bringing in the cutting-edge technology. Vida, would you like to elaborate on that, please?
Yes, of course. So absolutely. So again, the answer is yes. New technology can absolutely help to improve the situation awareness for mariners. One thing that we have done in the Ocean Project is that we have made significant improvements in using cameras for obstacle detection, and also use radar and AIS data for automatic detections, and fuse these together and then presenting it in a view. Yeah, we have mainly tested daylight cameras, but also infrared cameras is possible to use, and combined with radar and AIS, so it will support the mariner in most weather conditions. So and we use this information then to also detect collision risk. So yeah, first we have the collision risk when we enter an area of containers or whales, where we get kind of advice on reducing the speed, and then we also, when detecting vessels on collision course, we also get an early risk of collision warning. Where we also see the red dotted line is the route we are following, and we see a blue line which is a suggested maneuver. And then if the mariner is not taking action, we get a new increased risk of collision warning, and now red, and also with last time to maneuver indication. Still, it's up to the mariner to follow the advice and do the actual maneuver. But we also have demonstrated that if no actions are taken, the evasive maneuvering agent will actually take control and do a maneuver. So we believe that this kind of the improvements we have done in automatic detection of targets, vessels, and so on, and also giving risk advice, collision risk advice, is much improving what the mariner can do.
Thank you. Thanks a lot, Rita. I think it's worthwhile to stress that we don't see this as an autonomous system as such. We see it as decision support for the operator. We see it as helpful to the operator to understand the situation and to suggest what the operator could do. And it is only in the very, very, very unlikely case that no action is being taken throughout a number of stages that we envisage that technology could actually step in and do something automatically. I think that's very important. It's a very cautious approach. So we are. Yeah.
Absolutely agree on that. So the main issue is to give better information to the buyer.
So we are in a way approaching the presentations, but there's one pertinent question remaining, and that is seen from an end user's perspective. Is any of this good, Brian? You are safety manager of the Irish Ferries, and you have been participating in the project, and you are what I see as a very, very competent representative of the professional shipping market and potential adopters of things coming out of the ocean. So what is your view on something like this?
Thanks, Eric. I'll do my best to fulfill that role that you describe. So yeah, I believe ocean solutions can bring significant real benefits in real life, especially if they're to be adopted across the industry. We've heard today the many different components of the ocean project, but there are 5 main solutions that stand out for me as a shipping company. So I'm just going to quickly run through those. So first, Ocean conducted a root cause analysis of marine incidents. Now, this has been done before, of course, but Ocean sought to apply new analytical methods to assess cause and effect, leading to the creation of new tools to assist management companies and the industry to self-assess their efforts to improve situational awareness and reduce navigational accidents. Second, the development of the 4D SAD. This tool, I think, displays data in a new, user-friendly, tactical manner. While at first it may look similar to an ECDIS, there are some exciting new features, such as the manner in which the most relevant data is displayed, and a 3D view, similar to a sat-nav or Google Maps. It also allows users to roll forward through time, being the 4th dimension, to see the results of planned and trial maneuvers, so enhancing navigational planning and execution. So this advanced visualization tool can help bridge the gap, I believe, between traditional navigation methods and modern technology, offering a more intuitive and interactive experience for users. Third is the open source reporting app that we've heard about. And this enables navigators and coastal authorities to crowdsource information about navigational hazards such as floating containers and the presence of marine mammals. So forgive me for yet another comparison to what we do on our phones, but it's very similar to the Waze or Google Maps driving apps, which allow drivers to report hazards as they drive. So this collaborative approach allows users to efficiently and effectively share valuable information with each other, so raising awareness of potential hazards in real time. Navigators may then either make changes to their planned routing, their speed, etc., or simply benefit from raised alertness levels without causing distraction, being aware of the latest hazards in the vicinity, ensuring navigators have the best opportunity to identify and avoid these hazards. Fourth, the Enhanced Navigation Hazard Infrastructure, EHNI, integrates various data sources to provide a comprehensive overview of the maritime environment. The system efficiently receives and disseminates information, presenting it on the 4D SAD or on the app, helping navigators to stay informed and make better decisions. And this has the potential, I think, to revolutionize the way we disseminate navigational warnings to the point where navigator has a live view of dynamic hazards. And finally, the Benoit's escalation that we've just heard about. I've been asked many times recently how it's possible for ships to collide, having apparently or allegedly taken no evasive action. By linking the 4D SAD to a bridge navigational watch alarm system, or Benoit's as we call it, assistance can be summoned to the bridge if a navigator fails to take action to avoid a clear and dangerous hazard. So if I'm going to summarize, I think Ocean offers not only theoretical tools to improve navigational safety, but also new bridge equipment that can provide a step change for how we navigate. And by leveraging these innovative solutions, the maritime industry can achieve a higher level of safety, reliability, and sustainability, contributing also to the protection of marine life and the environment. Back to you, Eric.
Thank you so much, Brian. I mean, I almost blush when I hear these words. It is so pleasing that a professional like you have this view on the ocean. So I'm really so pleased. What I'm less pleased about is my poor time management of this event. I had to apologize to people on the call. I was and I am looking forward to feedback. This is the most important bit, but apparently I misjudged how long time it would take to bring you up to speed on what I think are all the exciting things we have been doing. So I think that the next best thing is that we would so much love to have comments and questions and any kind of input or feedback from you. Kindly use the Ocean email address that is on this slide, ocean@hfield.no. It goes directly into my inbox. It goes directly into a number of other inboxes, and we will do our very, very best to give you a sensible response, either by pointing you to the Ocean participant who is best suited to do this, or trying to answer, or trying to direct you to deliverables that are available on our website. I am very sorry, I'm truly sorry that we will not have time for what I thought was actually the more important bit of this webinar, which was to hear from you. I really hope you will take the effort of sending us this kind of requests so that we can deal with them and we can establish a good conversation around Ocean and what we're doing here. And that gives me like 3 minutes and 51 seconds to close this. I hope that it has been interesting. You have heard about how we believe that we can share the oceans with marine mammals to the common benefit of everybody, making the whales safer. There are some whale species that are down to 250 individuals, and they are smack in the middle of shipping lanes into the North American ports, into Boston, for instance. And losing just a single animal is reducing the possibility of that species surviving on the planet. So this is how important it is. I would have liked to show you a video end-to-end of how we are using the information about containers from the moment they are lost or rather from the moment that people are warned about the potential loss to recovery. We have that available. I don't have time for it. I will make sure it is posted on the website. You have heard about human-centered design. This is really something we believe. We believe that technology and human factors can do a lot together and a lot more than what we have demonstrated here. I think this is a really an important thing for the project. You have heard how the ENHI and all the data sources combine and provide information to the mariners. What you haven't heard is that just the ENHI is just in quotation marks, and the app can create an ocean microsystem. So any local community can adopt the app and can start to build a crowdsourced warning mechanism, a crowdsourced information mechanism in their own community. And this is something we would very much like to support you doing to get for the safety of everybody. And then I have just 3 messages. It has been said many times. all the public things we have been doing are on the website. It's available to download. We are so much interested in having one-on-one conversations if you like that. So again, use the ocean@hvl.no email address if you have particular issues you would like to discuss, if you have particular kind of collaboration in mind. And then finally, and that is probably the last thing I'm going to say today, we will be having a final event in September where the project is finishing. It will be held at EMSA, the European Maritime Safety Agency in Lisbon. It will be a hybrid event. You are so welcome to attend either physically or virtually. And we just hope that there will be a great turnout for a day of a lot of exciting conversations and discussion of what can we do more for European maritime safety. So this is all from us. Thank you very much. I think I have 15 seconds to spare. So thanks to the team. Thanks to NI for organizing this. Thank you very much, all of you, all the partners, all the participants online. Thank you.